Okay, we are on 1.6. This is the last section of notes before your test. So there's 6 sections, and then you will have a test on Wednesday. Okay? So polygon, a closed plane figure with the following properties. It's formed by 3 or more segments, so like a triangle or bigger, or more sides, I mean. So a polygon has to be closed. So I couldn't just have 2 sides because then it's open. I'd have to have that 3rd side. Each side intersects exactly 2 sides, 1 at each endpoint, so that no 2 sides with a common endpoint are collinear. So anything with a circular side is not a polygon. Circle is not a polygon. So a triangle is a polygon. That's a polygon because it's all straight lines that connect. And then we have convex and concave polygons. Convex is a no line containing a side or polygon contains a point in the interior of the polygon. So concave and convex. Convex means it goes out, essentially. When I were to draw diagonals, so if I were to draw a diagonal in a convex polygon, all the diagonals would always be inside the figure. Okay? However, a concave polygon caves in. So like this up here was a concave polygon. So something like this would be a concave polygon. And if I were to draw its diagonals, they're not always on the inside. They go outside. So that diagonal is on the outside of that figure. So concave caves in. Convex is just goes out. Okay? N-gon is a way that we name polygons that have more than 13 sides. So like a 13-gon is a polygon with 13 sides. A 22-gon is a polygon with 22 sides. Equilateral, equa means equal, lateral or sides. So this would be a polygon that has all equal side lengths. When you measure them, they're all going to be the same size, so they could have a tick mark on all sides. An equiangular polygon is a polygon that has all equal angle measures. So we could put the arcs in them. A regular polygon would be a polygon that's both equilateral and equiangular. So it has to have both properties to be regular. You do need to know what these names represent, how many sides they represent. So a triangle is 3-sided. A quadrilateral is 4-sided. So a 4-sided figure is not called a square. It's not called a rectangle because these are all types of 4-sided figures. We call those quadrilaterals. Quad means 4. Pentagon is 5. Hexagon is 6. Heptagon is 7. Octagon is 8. Nonagon is 9. Decagon, like a decade, is 10 years, so 10 sides. Undecagon, un means 1. Dec is 10, so that would make 11 together. Dodecagon, do means 2, dec means 10, so that would make 12. And then this would be n number of sides. Anything about that, we call it n-gon, n number of sides. All right, next page. All right, tell whether the figure is a polygon, and if not, explain why, and if it is, tell whether it's a convex or concave. So this one's not a polygon. The reason is because of our circular sides here. This one is, yes, a polygon. And then I have to decide if it's convex or concave. So does it cave in or are all my sides out? Caves in right here, because if I were going to make a diagonal, it would be on the outside. So concave. This one again is a polygon. And this one would be convex, because it's all on the outside and all my diagonals would go on the inside. Classify the polygon by the number of sides, and then tell whether it's equilateral, equiangular, or regular. So go ahead and pause me and try those 4. Unpause me when you're done. So this one has 1, 2, 3, 4, 5 sides, so that's a pentagon. All side lengths are 3, so they're all equal, so it would be equilateral. All angle measures are equal because they have the arcs, so they would be equiangular. So we don't call it equilateral and equiangular. If it's both, we call it regular. Next one, 1, 2, 3, 4 sides, so that is a quadrilateral. I see all my sides are equal, but not all my angles are equal. These are equal to each other, and these are equal to each other, but they would all have to be equal together. So this is a, equilateral. Number 6 is a triangle. It has 3 sides. 2 of my sides are equal, but this one's not. 2 of my angles are equal, but this one's not, so it's just a triangle. It's not equilateral or equiangular. Next one, 1, 2, 3, 4, 5, 6, hexagon. These sides are equal, but it doesn't talk about these sides, so we can't assume that they're equal. These 2 and these 2 are equal to, so those 4 are equal, these 2 are equal, so they're not all equal together. So it's not equilateral, nor is it equiangular. All right, number 8. The lengths and feet of 2 sides of a regular quadrilateral. So a regular quadrilateral would actually be a square, because regular means all sides are equal and all angles are equal. They're represented by 8x minus 6 and 4x plus 22. Find the length of a side of a quadrilateral. Well, if it's regular, that means it's equilateral, which would mean that these 2 sides would equal one another. So I'm going to set them equal to one another to solve for x. Once I've solved for x, then I can plug it in and find the side length. Subtract 4x from both sides, so I get 4x. Add 6 to that side, so that is 28. I'm going to divide by 4 on both sides, so I get x equals 7. Once I've done that, I'm going to plug it back in. I'm going to do 4 times 7, and I can plug it into either because it'll give me the correct answer. Actually, I'm going to plug in right here. 8 times 7 is 56. 56 minus 6 is 50. So the side lengths are each 50 degrees. All right, next one. The expressions 3x plus 63 and 7x minus 45 represent the measures of 2 angles of a regular decagon. Decagon is 10 sides. Regular means it's equilateral and equiangular. So these angle measures are equal to one another, so I'm going to set them equal. They want me to find the measurement of the angles of this decagon. All right, so I'm going to subtract 3x from this guy, so that gives me 4x. I'm going to add 45 to this guy, that gives me 108. I'm going to divide by 4 on both sides. I get x equals 25, 26, 27, I believe. So x equals 27. But they want us to find the angle measure, so I'm going to plug that back in. Either one works. 3 times 27 plus 63 equals 144. All right, next page. Sorry, let me see how I can. Okay. The expressions negative 2x plus 41 and 7x minus 40 represent the lengths in kilometer of 2 sides of an equilateral pentagon. So pentagon's 5 sides, equilateral means that the side lengths are equal. Find the length of the sides, or a side, but it would be all the sides, right? So these 2 things are equal. I'm going to add 40 to here and I get 81. I'm going to add 2x to here and I get 9x. So divide by 9 and I get x equals 9. I'm going to plug it in. Does not matter which one, I'm just going to go into the 7x one. So 7 times 9 minus 40. So 7 times 9 is 63. 63 minus 40 is 23. So the lengths of all the sides are 23 kilometers. I have my units on that. Sorry about that. Okay. Tell whether the statements always, sometimes, or never true. These can be tricky. I want you to pause me and try 11 through 14 on your own, and then unpause me when you're done. A quadrilateral is convex. So, can I draw that? 1, 2, 3. So there it is, concave. And there it is, convex. So, sometimes, since I can draw it both ways. An octagon is regular. Well, an octagon could be regular. All sides and angles could be equal, but does it have to be? It does not. So that would be sometimes. A triangle is concave. So here's a triangle. Is there a way to make that triangle go out? No, because I would have to have one more side. So that would be never. A regular polygon is equilateral. Regular means, in the definition of regular, it means that it's equilateral and equiangular. So a regular polygon would always be equilateral. Draw a figure that fits its description. Okay, so on this, guys, on this guy, go ahead and do 15, 16, 17, and 19 on your own. Pause me, unpause me when you're done. So there's multiple ways to do this. So yours may look a little different than mine. Not regular. I'm not marking any sides or any angles to be equal. Concave, quadrilateral. So concave, four-sided figure. There we go. Pentagon that is equilateral but not equiangular. I typically draw a house, so if it's not equiangular. So on that, you just have to make sure that these sides are equal, so I'm going to mark that as those being equal. A quadrilateral is equiangular but not equilateral. So maybe a rectangle, right? Rectangle has all 90-degree angles, but the side lengths are not equal. These are equal and these are equal, but they're not all four equal together. Each figure is a regular polygon. Find the value of x. So if it's regular, all angle measures are equal and all side lengths are equal. So I know 2x would equal x plus 30. So I'm going to subtract 1x from both sides. So I get x equals 30. And all they want us to do on this is find the value of x. This one, if it's regular, all sides are equal, so set these equal. 3x plus 27 equals 3x plus 32. Sorry, 13. Subtract 3x, I get 10x. Subtract 27, and I get 5. Divide by 10, that is not 2. 5 divided by 10 is 1/2, or 0.5. So be careful on that. And then 21, again, those two things are equal. X squared plus 8 equals x squared plus 2x minus 2. I'm going to subtract x squared on both sides, which actually gets rid of it. So I get 8 equals 2x minus 2. I'm going to add 2. So I get 10 equals 2x. Divide by 2, and x equals 5. I actually want to do one more thing. Go to the back. I'm going to talk about a formula real quick. N minus 2 times 180 equals number of degrees in a polygon. That is the formula to find the number of degrees. So, for instance, if I have a 5-sided figure, or let's start with a 4-sided figure. So that would be 4 minus 2, which would be 2, times 180, which equals 360. The reason this works is that if you choose one corner of this polygon and you make a diagonal, as many diagonals as it would make, in this case it would only make one diagonal, but it splits it into triangles, and there's 180 degrees in a triangle. So that's really what you're doing on this formula, is finding how many triangles are in the figure and multiplying each of those triangles by 180 because they're 180 degrees. So like a pentagon, I think of a pentagon. If I start at this corner, I can draw a diagonal here, and I can draw a diagonal there. So that's 180 here, 180 here, and 180 here, which I would do 5 minus 2, which equals 3, times 180, and I get 540 degrees. Yeah, I think that's all. All right, thanks, guys.